this question, we're going to justify Pythagoras' theorem here. Oop. So use Pythagoras' theorem, investigate each of the angles marked theta in the following diagrams. Equals 90 is less than 90 or greater than 90. Justify your answers. Okay, so here's what we're going to do. Just going to get myself space here. So you're going to have to use Pythagoras' theorem for each triangle. So you get the largest side, which is known as the Pythagoras. Which is known as the hypotenuse. So you put 15 squared, the larger side squared. Does it equal the smaller sides squared and added together? So 15 squared is 225. Okay. 6 squared is 36 and 10 squared is 100. And what you can see is that 225 is clearly bigger than 136. This means the hypotenuse squared is bigger than the 6 squared plus the 10 squared. What essentially means is that the 15 is longer than the diagram gives it credit for, and what you're dealing with is actually an obtuse angle. Okay, so this is an obtuse angle which is bigger than 30. Obtuse. Sorry, which is bigger than 90 degrees, my fault. So this one here is an obtuse angle which is bigger than 90 degrees. Okay, we do the next one. We're going to get the largest side, which is 13 squared. We're going to equal it to the 12 squared plus the 5 squared. We're going to get 169 equals 144 plus 25. We're going to get 169 equals 169. Because it balances, this means it's a 90-degree angle, which means it's a perfect right angle triangle. Pythagoras' theorem always balances for right angled triangles. Okay, so this diagram is perfect. The angle in question is in fact a perfect 90-degree angle. Okay, finally, on the last page, the last one, we have 10 squared. Does it equal 8 squared plus 7 squared? Well, we know this is 100. We know this is 64. And we know 7 squared is 49. And in this case, 100 is smaller than 64 plus 49, which I believe is 113. This means that the length was shorter than we thought it was. So when we think of this line here, it's actually not as long as it's depicted, and therefore this angle here, which we thought is 90, is now a lot smaller than 90. Well, in the first question, this angle is a lot bigger than 90. So this means a Q angle less than 90 degrees. Okay, we all good with that? All right. Next question then is the bottom three questions, which I can do here. So we're going to do Pythagoras' theorem for all three of them. So I'll start off by doing Pythagoras' theorem for all three questions, okay? So we get is 15 squared equals 12 squared plus x squared. 225 equals 144 plus x squared. 225 take away 144 equals x squared. 81 equals x squared. X must equal 9. Because you squared 81 to get 9. Okay, on the next question, so I haven't answered this question completely yet. I'm just finding the x values first, and I'll find sine theta, cos theta, and tan theta afterwards, okay? So the next question is going to be x squared is the longest side, and that equals 12 squared plus 16 squared. X squared equals whatever 12 squared plus 16 squared is, so what's 12 squared plus 16 squared? We get 400. X has to be the square root of 400. What number, when you multiply it by itself, gives you 400? X will have to equal 20. So then on this question, we now know that x equals 20. So that one's 20, and that one's 9. Whoops, perhaps best not do that. Idea for both of them. Okay, and finally the last one, which you're going to have is 7 squared equals 6 squared plus x squared. 49 equals 36 plus x squared. The 36 has to go to the other side, so it's going to be 49 take away 36 equals x squared. 49 take away 36 is 13 equals x squared. And the square root of root 13 is just simply root 13. You just got to leave it like that. That's what it means by surd fractions and surd form. Now that we know that this equals root 13, what we got to do next is we got to find sine theta, cos theta, and tan theta of all three questions, okay? So here's what we're going to do. So the rhyme we have is silly old Harry chased a horse through our attic. So silly old Harry chased a horse through our attic. And essentially what that means is sine, cos, tan. Sine of an angle is your opposite divided by your hypotenuse. Cos of an angle is your adjacent divided by your hypotenuse. And tan of an angle is your opposite divided by your adjacent. Now to figure out which one is the hypotenuse, opposite, and adjacent, here's what we need to do. Well, the first thing you're going to know is that no matter what, the longest side in the triangle is always the hypotenuse. So this is the hypotenuse, 20 is the hypotenuse, and 7 is the hypotenuse. The next thing you need to do is you need to look at what angle you're targeting. You're targeting which angle you're using in each question. Now, whichever side looks at that angle is the opposite. So this makes 12 the opposite in the first one, also makes 12 the opposite in the second one. But oddly enough, because you're using a different angle in the third one, it's actually root 13 is the opposite in the third one. By process of elimination, the last angle is the last side is the adjacent. So that means 9 is the adjacent in the first one, 16 is the adjacent in the second one, and 6 is the adjacent in the third one. Now what you got to do is we got to write down sine theta, cos theta, and tan theta, and we're going to have to do this 3 times, okay? So lucky for me, I think I can copy this or clone it. Control D, Control D. All right, so we're going to have to do just 3 triangles, so it means there's going to be a good few of these, okay? Like so. Now let's start off with the first one. Sine. What do we use for sine? We use the opposite over the hypotenuse. So it's going to be 12 over 15 in the first triangle. In the second triangle, opposite over hypotenuse will be 12 over 20. And 12 over 20, actually we can break the two of these down, guys. 12 over 15 in the calculator, you put 12 over 15 into the calculator, you actually get 4 over 5, okay? And 12 over 20 in the calculator is actually 3 over 5, okay? So far so good. And then the next one is the opposite, which is root 13. Once again divided by the hypotenuse, which is 7, and we can't do anything with that in the calculator. Next thing we're going to move on is to the causes, which is adjacent of the hypotenuse. And the first one, the adjacent is 9. The hypotenuse is still 15. Enter that into your calculator, you'll get 3 over 5. Next, in triangle 2, the adjacent is 16 and the opposite and the hypotenuse is 20, so it's 16 over 20. Put that into your calculator, you get 4 over 5. And finally, cos theta in the third one. The adjacent is 6 and the hypotenuse is 7, so it's going to be 6 over 7. Happy days. Now, on the third triangle, we're next going to do tan. Tan is opposite divided by your adjacent. So in the first triangle, it's 12 divided by 9, which is 4 over 3. In the second triangle, it's 12 divided by 16, which is 3 over 4. And finally, in the last one, it's opposite over adjacent, which is going to be root 13 over 6. Okay, guys, and that is those questions. Took 10 minutes, right? Chat to you later.